Hello students, how are you all? I hope that you all are good. As we know, the series of motion in a plane is going on and we are successfully finished the 3 lectures, right? So in a previous lecture that we are discussed about addition of two vectors by using head and tail method as well as triangle law of vectors. So the resultant of addition of two vectors in case of triangle law of vectors, we got r bar is equals to under root of a square plus b square plus 2ab cos theta. We are taking the vector a bar as a reference line. From that reference line, the resultant vector r bar is at an angle alpha. So then we got the equation. The direction of the resultant vector r bar is equals to tan alpha is equals to b bar sin theta by a bar plus b bar cos theta. Okay, and we are solved some example problems on that concept, right? I hope that you are understood that concept. Okay, right. So in today's lecture that we are going to discuss about addition of two vectors part 2. In this lecture that we are going to discuss one important concept, that is a parallelogram law of vectors. Okay, so this is an important concept and we have some applications on this concept. Okay, so watch the lecture carefully and prepare the notes well. Okay, right. So my name is Rakesh. Welcome to our beautiful physics channel, Rakesh sir Physics. Shall we start the session? Right. So what is the chapter going on? Motion in a plane. What is the class number? This is the class number 4. Okay. What is the topic? Addition of two vectors. And this is a session number 2. Okay. What is the today's concept? Today's concept is what? Parallelogram law of vectors. Parallelogram law of vectors. Okay. Right. Have a look. The statement of parallelogram law of vector addition. Have a look. Statement. The statement is, if the two vectors are drawn from the same point or taken from the same point, drawn from the same point as to represents the adjacent sides of a adjacent sides of a parallelogram, adjacent sides of a parallelogram, both in direction and magnitude, both in direction and magnitude. Okay, let us consider this is a point number 1. Okay, so what they are saying, if the two vectors are drawn from the same point, if the two vectors are drawn from the same point as to represent the adjacent sides of a parallelogram, both in direction and magnitude. Have a look. So based on this statement, I am just going to draw the parallelogram. So from the same point, okay, I am just taking the two vectors. Okay, so this is the a bar vector, and from this point again I'm just drawing the b bar vector. Okay, so these two vectors are represents the adjacent sides of a parallelogram, both in direction and magnitude. So that means I'm just taking the adjacent sides of a parallelogram, right? So this is a another vector. Okay, if this is a bar, then opposite vector is also a bar, because in case of parallelogram the opposite sides are same. If this is b bar, then this is also becomes b bar. Okay, so according to this condition and just draw the parallelogram. So the diagonal of the if the parallelogram diagonal of the parallelogram is also taken from is also drawn from or taken from the same point, the same point which gives which gives the resultant of which gives the resultant of two vectors, which gives the resultant of the two vectors both in direction and magnitude. Direction and magnitude. Are you getting? Right now what we have to do, if the diagonal of the parallelogram is also taken from the same point. So what we have to take? We have to take the diagonal of the parallelogram from the same point. From the same point. So from this point, I am just drawing the diagonal of the parallelogram. So draw the straight line. Okay. Right. So this is what diagonal of the parallelogram, and it represents what? The resultant of the two vectors. Resultant of the two vectors both in direction and magnitude. Are you getting? Now the diagram part is over. Okay, ma'am. Now I'm going to do the calculation part. Okay, have a look. I'm just taking the angle between these two vectors a bar and b bar. Let us say an angle theta, where theta is the angle between a bar and b bar vectors. Right. In a previous lecture, in case of vector addition by using triangles law, what we are did? So we are drawn one perpendicular line. Okay. So and we are extended the vector a bar. So the same thing here I did. Okay. Right. Have a look. This is the b bar vector. This is the b bar vector, and this is also the b bar vector. This is also b bar vector. Have a look. So this is b bar vector, and this is also the b bar vector. Okay. So this b bar vector is making an angle theta with the base. This b bar vector making an angle theta with the base. Here also, this is the b bar vector and this is the base. Now, what is the angle between b bar vector and the baseline? How much more? Theta. Are you getting? I'm just going to give the name for parallelogram. This is O, P, okay, Q and the S. So this is the name of the parallelogram. What is that? O, P, Q, R, S. Right? Okay, sir. Right. I'm going to do the calculation. So please pause the video and write the statement. Okay. 3, 2, 1, go. Right. Okay. Let us do the calculation part. Calculation. Right. So I'm just taking the triangle QRS. I'm taking the triangle QRS. Have a look. Right. So this is Q, R, S. Okay. Are you getting ma? So this is an angle theta. Okay. So this is what? This is a B bar vector. Okay. So this is what? 90 degrees, and it is a right angle triangle. So as we know from right angle triangle, I'm just going to write the values of cos theta and sin theta. So what is cos theta? First one. What is cos theta, ma? Adjacent side by hypotenuse. Cos theta is equals to what? Adjacent side by hypotenuse. So cos theta is equals to what is adjacent side? RS. And what is hypotenuse? B bar is the hypotenuse. Have a look. This is the hypotenuse. So from this, I'm just going to find the side RS. Okay. So RS is equals to, we got B bar cos theta. RS is equals to how much, ma? B bar cos theta. So RS is equals to how much? B bar cos theta. Are you getting? Any doubts? Okay. Next, I'm going to find the second one, that is a sin theta. What is sin theta? Sin theta is nothing but what, ma? Opposite side by hypotenuse. Okay. Then sin theta is equals to what? Opposite side? The side which is opposite to an angle theta. What is that? QS divided by what is hypotenuse? Hypotenuse is B bar. So from this we can write out QS is equals to B bar sin theta. The side QS is equals to how much, ma? B bar sin theta. QS B bar sin theta. Are you getting any doubts? Simple mathematics. Okay. Right. Next, to find a resultant vector. To find resultant vector, and just considering we use OQS triangle. We use triangle OQS. Are you getting any doubts? Have a look. This is a big triangle. OQS. Have a look from the triangle OQS. This is a rough diagram of triangle OQS. Okay. What is OQ? OQ is nothing but vector R bar. So this is a vector R bar. Okay. So what is the OS? OS. From here to here, vector A bar. From here to here, B bar cos theta. Then the length of the total side is how much? A bar plus B bar cos theta. So OS is equals to how much, ma? A bar plus B bar cos theta. Just right here. A bar plus B bar cos theta. Okay. QS. What is QS? QS is equals to how much? B bar sin theta. B bar sin theta. Have a look. Again, this is a right angle triangle. Okay. What we need? We have to find resultant vector. We have to find resultant vector. Have a look. This is a hypotenuse. Okay. In case of right angle triangle, if we know the values of two sides and if we want to find the third side value, which formula we use? We use Pythagoras theorem. That is what? Hypotenuse square is equals to side 1 square plus side 2 square. Okay. Right. From this, what is hypotenuse here? R bar square. R square is equals to side 1 square. Let us say this is a bar plus B bar cos theta whole square plus what is side 2? B bar sin theta whole square. Are you able to see the board? Okay. Right. So just I'm expanding this term. Okay. So R bar square is equals to, so A plus B whole square. A plus B whole square. At the place of A, we have capital A, and at the place of small b, we have B bar cos theta. B means what, ma? B bar cos theta. A plus B whole square. A square plus B square plus 2AB. Okay. Right. At the place of A, we have capital A. So I'm just using A plus B whole square formula. That is A square plus B square. B means what? B cos theta. So B square cos square theta plus 2 into A B bar cos theta 2AB plus here we have B square sin square theta. So B square sin square theta. Are you getting? Simple mathematics, ma. Okay, simple mathematics. So R bar square is equals to, here we have A square plus here B square cos square theta is there, here B square sin square theta is there. I'm just taking the common B square. Have a look, B square, B square. I'm just taking the common B square. Then we will get cos square theta plus sin square theta plus here we have 2AB cos theta, 2A bar B bar cos theta. Here plus, okay. So plus 2A bar B bar cos theta. Are you getting? Any doubt? Okay. So cos square theta plus sin square theta. This value becomes how much, ma? 1. So 1 into B square, B square. So finally, resultant square is equals to A square plus B square into 1, B bar square plus we have 2A B cos theta. Okay. So if square went to that side, it becomes root. So R bar is equals to under root of A square plus B square plus 2AB cos theta. So this is the resultant of the two vectors. This is what? The addition of resultant of these two vectors. What is that? R bar is equals to under root of A square plus B square plus 2AB cos theta. Are you getting? Right. Where capital A bar and B bar are two vectors. Are what? Two vectors. Okay. What is theta? Where theta is angle between, theta is what, ma? Angle between the A bar and the B bar vectors. A bar and the B bar vectors. Okay. Are you getting? Any doubts? Okay. So I'm just going to find the direction of resultant vector. What I'm going to find? The direction of resultant vector, that is R bar. Okay. Right. To find the direction of the resultant vector R bar, okay, I'm taking A bar vector as a reference line. A bar vector as a reference line. Okay, this is what? Reference line. So from this reference line, A bar vector, the R bar vector is at an angle alpha. The R bar vector is at an angle alpha. Now, the resultant vector R bar is at an angle alpha from capital A bar vector. In a previous lecture, I told you that if you want to find the direction, which trigonometrical function gives the direction? Tan alpha. Now, find the tan alpha. Find the tan alpha. It gives direction of R bar. It gives what more? Direction of R bar. Are you getting any doubts? Right. So to find the direction of R bar, I'm just taking the triangle from triangle. Okay, I'm just taking the triangle that is a OQS. Which triangle I'm using? OQS triangle I'm using. Okay, right. Have a look. OQS. OQS. So this angle is how much? Alpha, and this is R bar vector. This total side is how much more? A bar plus B bar cos theta. And this side is how much more? B bar sin theta. B bar sin theta. Are you getting? Okay. So from this, I'm going to find out tan alpha. I'm going to find tan alpha. What is tan theta? In general, tan theta is nothing but what more? Opposite side by adjacent side. Okay. So then tan alpha is equals to, this is alpha. What is opposite side? The side which is opposite to an angle. So what is that? B bar sin theta divided by, what is the adjacent side? A bar plus B bar cos theta. A bar plus B bar cos theta. So this equation gives what? Direction of, this equation gives direction of R bar vector. So what is that? Tan alpha is equals to B bar sin theta by A bar plus B bar cos theta. Are you getting? Right. So note, if B bar is taken as, reference line, B bar is taken as reference line. Now I am taking the B bar vector as a reference line, and R bar makes an angle beta. Here I am taking an angle beta with a B bar vector. So at this time we are taking the vector B bar as a reference line. Okay, this is a reference line. Now with this reference line, this R bar vector is making an angle beta. Is making an angle what more? Beta. Now the direction of R bar from B vector is given by tan beta. Tan beta is equals to, have a look, here we have B bar sin theta, when we take the A bar vector as a reference line, now we are taking B bar vector as a reference line. Now this B bar becomes A bar sin theta divided by, this A bar becomes B bar plus A bar cos theta. Are you getting ma? Just at the place of B bar you will get A bar, at the place of A bar you will get B bar. Okay, right. So pause the video and write the notes. I hope that you are understood the concept. Okay, right. So pause the video and write the notes. 3, 2, 1, go. Right. So let us see the note number 1. Note number 1. If the magnitude of A bar vector, is greater than is greater than b bar vector is greater than b bar vector. That means just the line a bar vector is more than b bar vector, magnitude of b bar vector. Have a look. Now what happened? The resultant of these two vectors is like this. The resultant of these two vectors is like this. You will get like this. Okay. Right. What is this? This is an alpha. Okay. Now this is what? Beta. So from this diagram, it is clear that this beta, this angle is greater than what? Alpha. Beta is greater than alpha when the magnitude of the vector a bar is greater than b bar. When beta is greater than alpha. Now what happened, Then the resultant vector, then the resultant vector is the resultant vector is shifted towards a bar, is nearer to is nearer to the vector having larger magnitude. Larger magnitude. Are you getting me? So whenever the magnitude of a bar vector is greater than b bar, then what happened? The resultant vector is nearer to the vector having the larger magnitude. That means now this r bar vector is shifted towards a bar vector. Are you getting? Okay. If the magnitude of the b bar vector is more compared with a bar vector, then what happened? This resultant vector is shifted towards b bar vector and it is nearer towards b bar vector. Are you getting? Right. So, note number 2. Okay. So, what is an angle theta? An angle theta is the angle between two vectors. If angle between two vectors is increases, if the angle between the two vectors is increases, the angle between the two vectors is increases, theta is increases, then the resultant vector, then r bar, the resultant vector is decreases. Is what? Decreases. Okay. So whenever the angle between the two vectors is increases, then the resultant vector is decreases. What is the resultant vector equation we got? Under root of a square plus b square plus 2ab cos theta. If theta value is increases, then cos theta value is decreases. Then cos theta value is decreases. Have a look. From 0 to 90 degrees, cos theta value is positive. From 90 to 180, cos theta value is negative. Cos theta value is negative. Then this term becomes negative. Plus becomes what? Minus into plus minus. So overall answer is decreases, because if theta increases, cos theta tends to negative after 90 degrees. Then overall the resultant vector is decreases. Are you getting? So pause the video and write the notes. 3, 2, 1, go. So let us see the applications of parallelogram law of vectors. Have a look. So what is the resultant vector we got? R bar is equals to under root of a square plus b square plus 2ab cos theta. Okay, this is we got. And what is our tan alpha? Direction of the vector, resultant vector. Tan alpha is equals to b bar sin theta by a bar plus b bar cos theta. Okay, so these are the two equations we got. Are you able to see the board? Okay, right. So these are the two equations we got in case of addition of two vectors. Okay, right. Application number 1. Application number 1. If the two vectors, are parallel to each other, if the two vectors are parallel to each other. Okay, that means this is a bar vector and this is a b bar vector. Now these two are what? Parallel to each other. So when the two vectors are parallel to each other, then angle between them is how much more? 0 degrees. Then the resultant vector r bar becomes under root of a square plus b square plus 2ab cos theta. What is an angle theta? 0 degrees. Just substitute here. So we get under root of a square plus b square plus what is the value of cos 0 degrees? 1. This is the value of cos 0 degrees, 1. 1 into 2ab. We will get 2ab. So that is equal. So this is in the form of what? A square plus b square plus 2ab. We can write a plus b whole square. So we can write a plus b whole square under root. Okay. So from here, square root get cancelled out. Then we got r bar is equals to how much ma? A plus b, and this is called out, and this is called out maximum resultant. What is this? This a plus b. Now this a plus b is called what ma? Maximum resultant between the two vectors. What is that? A plus b. This is called what ma? R maximum. Resultant of the two vectors is maximum when the two vectors are parallel to each other. Okay. Right. Application number 2. So that is when the two vectors are opposite to each other. That means let us consider this is a bar vector and this is what? B bar vector. Have a look. These two vectors are opposite to each other, and when the two vectors are opposite to each other, what is the angle between them? Theta is equals to 180 degrees. Okay. Now what is the resultant vector? R bar is equals to under root of a square plus b square plus 2ab cos theta. What is the value of theta? 180 degrees. Cos 180 degrees. What is the value of cos 180? Minus 1. What is the value of cos 180 ma? Minus 1. So this cos theta becomes minus 1 when we are substituted 180 degrees. Minus into plus minus. So r bar is equals to we got under root of a square plus b square minus 2ab. Minus 2ab. Are you getting? So here theta is equals to 180 degrees. Cos 180 minus 1 minus into plus minus 2 into ab 2ab. That's it. Okay. Let's have a look. A square plus b square minus 2ab. A square plus b square minus 2ab. It is in the form of what now? R bar is equals to a minus b whole square. A minus b whole square under root. So here square root get cancelled out. Then finally you will get r bar is equals to a bar minus b bar. A bar minus b bar. Have a look. This is a plus b. And what is this? A minus b. This is the minimum value of resultant vector. What is this? The minimum value of resultant vector. Are you able to see the board? Okay. Right. R minimum is equals to we got how much ma? A bar minus b bar. So what is R maximum? A bar plus b bar. Are you getting? Any doubts? Okay. Right. Let us see the application number 3. Right. What is the value of R maximum we got? R maximum is equals to A bar plus B bar. What is the value of R minimum we got? R minimum is equals to A bar minus B bar. A bar minus B bar. Just I am doing like this. So R maximum divided by R minimum. R maximum divided by R minimum. That is equals to A bar plus B bar divided by A bar minus B bar. Are you getting more? Just dividing these two equations. Okay. So this is also one of the formula. From above equation, we can write. From above equation, we can write. So just bring this out. A bar minus B bar to this side and R minimum to that side. Have a look. R maximum into A minus B. R maximum into A minus B. So just bring this R minimum to that side. R minimum into A bar plus B bar. Okay. Just multiply with these things. So R maximum into A bar minus R maximum into B bar. This is equals to R minimum into A bar plus R minimum into B bar. Okay. So bring all the A bars to one side and bring all the B bars to one side. Are you getting? Okay. So R maximum into a bar. So bring this r minimum a bar to this side. It becomes minus r minimum into a bar. So that is equals to, here we have r minimum b bar. So bring this r maximum to that side. R maximum b bar. Are you getting now? And just separated a bars one side and b bars one side. So if I take a common a bar, so then you will get r maximum minus r minimum. R maximum minus r minimum into a bar. This is equals to, if you take a b bar common, if you take b bar common, you will get r maximum plus r minimum. Are you getting? Just bringing this a bar to this side. Now it becomes a bar. Here it is in multiplication. If it is comes to this side, it becomes denominator. So a bar by b bar is equals to, so here we have r maximum plus r minimum divided by, if this term went to that side, it becomes r maximum minus r minimum. Simple mathematics now. Okay, don't get attention. So this is also the formula for a bar and b bar vectors in terms of maximum and minimum resultant vectors. Okay, so r maximum by r minimum is equals to, we can write a bar plus b bar by a bar minus b bar, or a bar divided by b bar is equals to, we can write r maximum plus r minimum divided by r maximum minus r minimum. Is it clear? Any doubts? Simple mathematics. Okay, right. Okay, right. So let us see the application number 4. Application number 04. Okay, right. At this time, I'm taking the two vectors. The angle between two vectors, the angle between two vectors is 90 degrees. The angle between the two vectors is how much now? 90 degrees. That means they are perpendicular to each other. This is a bar vector and this is b bar vector. Now angle between them is how much? 90 degrees. Now what is the resultant vector? What is the formula for resultant vector? R bar is equals to under root of a square plus b square plus 2ab cos theta. What is an angle theta here? The angle between the two vectors, 90 degrees. What is the value of cos 90? 0. Cos 90 value is how much more? 0. Already we have discussed in our previous lectures. Basic mathematics used in physics, trigonometrics by Rakesh sir. You will get all these things. If you search that chapter, you will get all these things. Okay. So cos 90 value is how much? 0. 0 into something? 0. Then we will get r bar is equals to under root of a square plus b square. A square plus b square. Are you getting? Any doubts? Right. So let us see the application number 5. Application number 05. Okay, have a look. The resultant vector r bar, the resultant vector is what ma? R bar is perpendicular to the vector having smaller magnitude, okay. Then have a look. Here I am taking the vector a bar and the magnitude of the vector a bar at this time is small. Okay, right. I am taking the b bar vector. At this time, the magnitude of the b bar vector is more. So what is our condition? The resultant vector r bar is perpendicular to the vector having smaller magnitude. Whatever the vector having the smaller magnitude, with respect to that vector, the resultant vector is perpendicular. So a bar is what? Having smaller magnitude. Now the resultant vector is perpendicular to the vector. So this is what? R bar vector. Now already we have discussed the direction of the r bar vector from a bar vector is given by what? An alpha degrees. Okay, an alpha. So what is the angle between them? 90 degrees. Angle between them is what now? 90 degrees. That means alpha is equals to how much? 90 degrees. Alpha is equals to how much? 90 degrees. Okay, right. So what is an angle theta? Theta is nothing but the angle between a bar and the b bar vectors. Theta is nothing but what? The angle between a bar and b bar vectors. Let us consider the angle between r bar vector and b bar vector is phi. So what is phi? Phi is the angle between b bar vector and the r bar vector. Are you getting? Okay, right. Have a look. What is the value of alpha? Alpha is equals to 90 degrees. Okay. What is the formula for direction of resultant vector from a bar vector? This is the formula. What is that? Tan alpha is equals to b bar sin theta by a bar plus b bar cos theta. A bar plus b bar cos theta. What is alpha here? 90 degrees. So tan 90 degrees is equals to b bar sin theta by a bar plus b bar cos theta. Are you getting any doubts? Okay. What is the value of tan 90? Tan 90 is equals to how much, ma? Infinite. What is the value of tan 90? Infinite. So finally we got infinite is equals to b bar sin theta by a bar plus b bar cos theta. Infinite is equals to how much, ma? Bar sin theta divided by a bar plus b bar cos theta. Okay, right. So pause the video and write the notes. I'm just going to rub this part. So pause the video and write the notes. 3, 2, 1, go. Right. So what we got? We got a b bar sin theta divided by a bar plus b bar cos theta is equals to infinite. Okay. What is infinite? Infinite is nothing but what? Where we will get infinite? Something divided by 0. Infinite is nothing but what, ma? Something divided by 0. Are you getting? Infinite is nothing but what? Something value divided by 0. Then you will get how much? Infinite. You can write this equation as infinite is nothing but what, ma? Something divided by 0. Are you getting? That means something b bar sin theta is equals to something. There exists some value. That means b bar sin theta is not equals to 0. B bar sin theta is not equals to 0. There exists some value. But here we have a look. A bar plus b bar cos theta is equals to how much? 0. Is equals to how much, ma? 0. Okay. So b bar sin theta is not equals to 0, but the value of a bar plus b bar cos theta is equals to 0 from this condition. Okay, right. So if a bar went to that side, it becomes what, ma? So b bar cos theta is equals to minus a bar. Okay. If b bar went to that side, it becomes cos theta is equals to minus a bar divided by b bar. Minus a bar divided by b bar. What is theta? Where theta is angle between a bar and the b bar vectors. Okay. So whenever the resultant vector is perpendicular to the vector having the smaller magnitude, then the angle between the two vectors is given by cos theta is equals to minus a bar by b bar. Okay. And the resultant vector r bar is equals to what, ma? In general we have a square plus b square plus 2ab cos theta. 2ab cos theta. Right. In this case we got cos theta is equals to how much, ma? Cos theta is equals to minus a bar divided by b bar. Okay, just substitute here. So you will get r bar is equals to the root of a square plus b square plus 2ab into what is cos theta? Minus a bar by b bar. Okay. So here b get cancelled out, plus into minus a into a square. Then resultant vector r bar is equals to under root of a square plus b square plus into minus 2 a into a square. Okay. So you can write r bar is equals to how much? Under root of b square a square minus 2a square. A square minus 2a square. You will get minus a square. So this is the resultant of the two vectors when the resultant vector is perpendicular to the vector having the smaller magnitude. Are you getting? Right. So pause the video and write all these things. Okay. So important one. We have some problems on this concept. Okay. Right. So pause the video and write the notes. 3, 2, 1, go. Right. So let us see the application number 6. Application number 6. Okay. Right. Have a look. If the magnitudes of if the magnitudes of two vectors is the same. The magnitude of the two vectors is same. That means what, ma? So magnitude of a bar is equals to b bar vector. Are you getting? Right. Now what is the resultant vector? R bar is equals to, we get under root of a square plus b square plus 2ab cos theta. Okay. So where a bar is equals to what? B bar. That is equals to under root of a square plus b is nothing but what, ma? A square plus 2 into a into what is b? B is nothing but again a into cos theta. Okay. So that is equals to under root of a square plus a square, 2a square plus 2 into a, 2a square. Are you getting? 2a into a square cos theta. Okay. So if I take 2a square common, if I take 2a square common inside the root, so you will get 1 plus cos theta. Are you getting? So 2 into 2a square into 1, you will get 2a square plus 2a square into cos theta, 2a square cos theta. Already I told you that. What is the formula for 1 plus cos theta? 1 plus cos theta is nothing but 2 cos square theta by 2. This is the formula for 1 plus cos theta. Just substitute here. That is equals to under root of 2a square into 1 plus cos theta is equals to what, ma? 2 cos square theta by 2. That is equals to under root of 2 into 2, 4a square cos square theta by 2. Okay. Right. So resultant vector r bar is equals to, so if 4 comes from the root, it becomes 2. Okay. 2 square is nothing but 4. So square root get cancelled out, then 2 will be remains. A square, if a square comes from root, it becomes a. So square root get cancelled out. Here cos square theta by 2 is there. So square root will cancel out and you will get cos theta by 2. So what is the value of resultant vector r bar? So that is r bar is equals to 2a cos theta by 2. 2a cos theta by 2. Are you getting now? Any problem is there? No problem, sir. Simple mathematics, sir. Okay. Let us see the direction. What is the formula for direction? Tan alpha is equals to b bar sin theta by a bar plus b bar cos theta. We have a bar is equals to b bar. Then we can write tan alpha is equals to, are you getting? Mathematics ma, completely basic mathematics. Okay. What is b bar? B bar is nothing but a bar sin theta divided by a bar plus what is b bar? B bar is equals to a bar cos theta. That is equals to a bar sin theta divided by, if you take a bar common, then you will get 1 plus cos theta. Okay. A bar common, you will get 1 plus cos theta. So a bar get cancelled out. Sin a, have a look, we can write this equation as sin theta is equals to 2 sin theta by 2 into cos theta by 2. 2 sin theta by 2 into cos theta by 2. What is 1 plus cos theta? 2 cos square theta by 2. Just substitute these two formulas here. Then you will get sin theta becomes what, ma? 2 sin theta by 2 into cos theta by 2 divided by 1 plus cos theta, 2 cos square theta by 2. So from here 1 cos square theta by 2, 1 cos theta by 2 get cancelled out. So 2 get cancelled out. Finally we get sin theta by 2 divided by cos theta by 2. So we got tan alpha. Tan alpha is equals to sin divided by cos, sin theta by cos theta, tan theta. We got tan, at the place of theta we have theta by 2. Are you getting? Any doubts? Simple mathematics now. Let us see the application number 7. the magnitudes of the difference between two vectors. Magnitude of the difference between two vectors. Okay, that means the two vectors are equal. A bar is equals to B bar. So magnitude of the difference between the two vectors means we just taking the A bar vector, okay, and this is what B bar vector, and angle between them is theta. So magnitude of the difference between two vectors is nothing but what? A bar is equals to B bar. But magnitude of the difference between the two vectors means A bar is equals to minus B bar. A bar is equals to what, ma? Minus B bar. So A bar is equals to minus B bar. At what angle you will get? If you wanted to get minus B bar, so just draw the negative vector for B bar vector. So this is what? Negative vector of B bar. Have a look. Here is an angle theta. This total angle is how much? 180 degrees. So this is theta. This total angle is 180 degrees. Then what is the remaining angle between A bar vector and the B bar vector? Theta is equals to 180 minus theta. So at theta is equals to 180 minus theta, you will get the magnitudes of the difference between two vectors. Just theta becomes 180 minus theta. Okay, right. So now what is the resultant vector? R bar is equals to under root of a square plus b square plus 2ab cos theta. Just substitute all these values. That is equals to under root of a is nothing but a square. What is b? B is equals to a square plus 2ab. What is the value of b? A cos theta. What is theta? Theta is equals to 180 minus theta. Cos 180 minus theta minus cos theta. Are you getting? That is equals to under root of a square plus a square. 2a square plus 2 into a square. 2a square cos 180 minus theta minus cos theta. I'm just writing directly now. Okay. So minus cos theta, minus into plus, minus 2a into a square cos theta. Are you getting? Okay. So finally the resultant vector r bar is equals to, if you take 2a square common here, if you take 2a square common, you will get 1 minus cos theta under root. Okay. Then r bar is equals to under root of 2a square 1 minus cos theta. What is the formula for 1 minus cos theta? 1 minus cos theta is equals to how much now? 2 sin square theta by 2. 2 sin square theta by 2. 1 plus cos theta. 2 cos square theta by 2. 1 minus cos theta. 2 sin square theta by 2. Just substitute 2 sin square theta by 2 here. 2 sin square theta by 2. So 2 to the 4, r bar is equals to 4a square sin square theta by 2. Okay, then r bar is equals to 4 comes from the root, it becomes 2. If a square comes from the root, it becomes a sin square theta by 2 comes from the root. Square root get cancelled out, it becomes sin theta by 2. So this is what the resultant of the two vectors when the magnitude of the difference between the two vectors. Just take an angle theta as 180 minus theta. That is gives what? The magnitude of the difference between two vectors. Okay, right. So pause the video and write the notes. Let's solve the direction. Pause the video and write the notes. 3, 2, 1, go. Right. So let us find the direction of the resultant vector in this case. So what is the equation for direction of resultant vector? Tan alpha is equals to b bar sin theta by a bar plus b bar cos theta. Okay. What is the theta here? Theta is nothing but 180 minus theta, and a bar is equals to what now? B bar. Okay. Right. So tan alpha is equals to b bar is nothing but a bar sin theta divided by what is a bar? A bar is nothing but a bar plus what is b bar? B bar is nothing but a bar cos theta. Theta is what now? 180 minus theta. Here also theta is nothing but what? 180 minus theta. So a bar sin 180 minus theta. In which quadrant it exists? Second quadrant. In second quadrant, sin is positive. So sin theta. Sin 180 minus theta, sin theta. If you take a bar common, so a bar plus a bar cos 180 minus theta minus cos theta. Are you getting? I am just writing directly. Okay. So if you take a bar common, a bar sin theta divided by a bar. I'm taking the common. So 1 minus cos theta. Okay, a bar get cancelled out. Right. So this is equals to, what is sin theta? 2 sin theta by 2 cos theta by 2. The same thing here I'm writing, divided by 1 minus cos theta. What is 1 minus cos theta? 2 sin square theta by 2. 2 sin square theta by 2. So 2 get cancelled out. 1 theta by 2, 1 sin theta by 2 get cancelled out. And finally we got cos of theta by 2 divided by sin of theta by 2. So this is what? Tan alpha. So from this we can write tan alpha is equals to sin by cos tan, cos by sin cot. You will get cot theta by 2. Tan alpha is equals to what, ma? Cot theta by 2. Are you getting any doubts? Okay. So these are the 7 application and the important applications. We have some problems on these applications. Okay. Right. So pause the video and write the notes. Pause the video and write the notes. I hope that you are understood all the concepts. Simple basic mathematics, ma. Okay. Just we are substituted all the values in the equations. Just we are playing with 2 equations only. So one is resultant vector and one is direction of resultant vector. On that 2 formulas we are substituted all these things, whatever the applications we are taken. So just what is a bar, what is b bar, what is theta, just we are substituted the things and we will get all the resultants like this. Okay, right. So pause the video and write the notes. 3, 2, 1, go. Right. So let us see the application number 8. How many applications are there, sir? We are killing our patients. Don't get attention. Okay. So please practice. You will get all these things. Okay. Application number 8. So formula, important one. We have the problems on this application. So that is if n cap is the unit vector, n cap is the unit vector, and it is parallel to, and it is parallel to sum of the 2 vectors, and it is parallel to sum of the 2 vectors, sum of the 2 vectors, that is a bar and b bar. Okay, so n cap is the unit vector and which is parallel to the sum of the 2 vectors. What are the 2 vectors? A bar and b bar. Then n cap is given by, n cap is given by, so n cap is equals to a bar plus b bar divided by magnitude of a bar plus b bar. So important formula, we have some problems on this formula. So whenever the unit vector is parallel to sum of the 2 vectors, then the resultant vector is given by n cap is equals to a bar plus b bar divided by magnitude of a bar plus b bar. Okay, right. So the application number 9. So the application number 9 is, okay, so I'm taking the parallelogram. So this is what? A bar vector and this is b bar vector. Okay, right. So this is a resultant vector and this is called what? Diagonal of the parallelogram. So I'm taking another diagonal, that is a s bar, diagonal s bar. Right. So from this diagram we can write what is r bar square? R bar square, resultant square is equals to what, ma? Already we have discussed a square plus b square plus 2ab cos theta. Actually it is root, but here I am taking r square. So if you make a square on either side, the square root get cancelled out. You will get r square is equals to this. And s square, this resultant square, you will get s square is equals to a square plus b square. Here minus 2ab cos theta. You will get what, ma? Minus 2ab cos theta. In the concept of subtraction of 2 vectors, I will explain how we will get this. Okay. So now you remember s bar is equals to in this direction. So the resultant of these 2 vectors is given by this one. Okay. So therefore we can write r square plus s square. I am just adding the squares of these 2 diagonals, or the resultant of these 2 vectors is equals to a square plus b square plus 2ab cos theta. So this is what? R square plus, what is s square? This one, a square plus b square minus 2ab cos theta. So minus 2ab cos theta plus 2ab cos theta get cancelled out. a square plus a square. You will get r square plus s square is equals to a square plus a square, 2a square plus b square plus b square. You will get 2b square. So r square plus s square is equals to, we got, if you take 2 common, a square plus b square. Okay, are you getting ma? Any doubts? Okay, I pause the video and write the applications. Any doubts? Okay, 3, 2, 1, go. Right. So this is the end of the today's lecture, and this is one of the big lecture. Okay, I hope that you are understood this concept. Please learn the concepts, then you can easily do the problems. Okay, we will meet on a next lecture. Until then, stay tuned. And this is Rakesh Kaniganti signing off. Jai Hind.